Greetings from sunny California, hoping the weather in Wyoming is still halfway warm, and the last few days of Math 924 have been quite productive. If you find at any time that I am speaking too quickly or you're having a hard time keeping up with this video lecture, please feel free to push pause at any time or watch the video as many times as necessary. Should any questions arise after watching this video and working on your homework assignment, please recall I need you to submit those questions via Moodle, and I will do my best to answer them as promptly as possible. The video lecture today contains three main objectives. Number one, define slope-intercept form for a linear equation. Number two, identify the slope and y-intercept. And finally, graph linear equations from this slope-intercept form. If you are following along on your notes outline sheet passed out in class, we are focusing on Roman numeral number 2, blank number 3, strategies for graphing a linear equation. Probably the most used strategy and the best time-efficient strategy is number 3, converting the linear equation into slope-intercept form. Converting the linear equation into slope-intercept form. Okay, so let's talk about what slope-intercept form looks like. Slope-intercept form of a linear equation is an equation that has been rearranged in order to solve for y. Another way to say this would be we would like to rearrange the equation so that the variable y is the only thing all by itself on one side of the balance beam. Okay, so let's talk about a few examples of what a slope-intercept form equation would look like. Recall that y must be by itself. So for example, we could have y equals 3x plus 7. Y is all by itself on the left-hand side of this balance beam. Another option would be to have y on the right-hand side of the equation, but most importantly that y is all by itself. So on the left-hand side would be our x variables and our constant term. This would also be a slope-intercept form. So let's look at a couple of equations that are not written in slope-intercept form. For example, 5x plus y equals 11. In order to get this into slope-intercept form, we need the variable y on one side of the balance beam all by itself. Therefore, we need to zero out these 5x's. In order to zero out these 5x's, we must put negative 5x's with them in order to form a zero pair. This would be just like when the student teachers came to our classroom and we used white pawns to represent positive x's and blue pawns to represent negative x's. Keep in mind that whatever we do to one side of the equation, we must do to the other. So I also must subtract 5x's on the right-hand side of this equation. That being said, these 5x's zero out, leaving y all by itself on the left-hand side. Because these are not like terms, we just are going to write them separately. I cannot subtract 11 minus 5x's because the x's are pawns and the 11 is not. Once we have the equation written or rearranged so that y is all by itself, our next task is to identify the slope and the y-intercept. The slope is the coefficient of the x's. That is, it is the number of x containers or pawns in the equation. The y-intercept is the constant, the number that is not attached to the variable. Please recall that when we identify a y-intercept, it must be written as a coordinate pair. It will not be written that way in the slope-intercept form of the equation, so we must think about how to convert that into a coordinate pair. Let's look at a few examples. Our task for the examples are going to be to find the slope, state the coordinates of the y-intercept, and then graph it. So if you recall from our previous definition, the slope is the coefficient of the x variable. So in this particular equation, if this is where the x variable is located, the coefficient sits right in front. So in this particular example, 1/3 is our slope. This leaves the number 8. 8 is the constant. It therefore is part of the y-intercept. As you may recall from class on Monday, the y-intercept must be written as a coordinate pair. Therefore, we would say the y-intercept of this equation is the pair 0, 8. This is how that particular equation would be dissected. Once we've identified the slope and the y-intercept, graphing this should be relatively easy and very quick. If I were to graph this equation, I would simply start on the y-axis and plot the point 0, 8. From that point, I am going to use my slope to find other points on the line. I will then start at 0, 8 and slope 1/3. If you recall the definition of slope, that means rise over run. So if I were to graph this particular equation, I am going to put my first point at 0, 8, and then I am going to rise 1 and run 3. As you may notice, this will fall off my graph paper. So instead of rising 1 and moving to the right 3, I am going to do that in the complete reverse direction. So therefore, I'm going to go down 1 and back 3, and there will be my next point. I could continue on that pattern, down 1, left 3, down 1, left 3, and there is the equation of my line. Let's try example number 2. This time, let's assume the equation is already in slope-intercept form. Which means y is already by itself. And the equation is y equals 5 minus 2x. First, I need to identify the slope. Recalling that the slope is the coefficient of the x variable, this value of -2 is my slope. It might be helpful to note that we can change -2 to be a fraction if we choose to divide it by 1. Mathematically, dividing a value by 1 does not change the number, but it simply makes it look like a fraction. If -2 is the y-intercept, if -2 is the slope, 5 is the y-intercept. So now we know that our y-intercept is at 0, 5, and our slope is -2 over 1. Converting that to a graph, I am going to place my first dot at 0, 5, my y-intercept, and then I'm going to follow my slope. Rise -2, run 1. The 1 that we added to the equation is not negative. Therefore, when I am finished graphing my linear equation, it should be headed downhill because the slope is negative. Oftentimes, it may appear as if part of the equation perhaps may be missing. So let's take, for example, y equals negative 3. This equation is technically written in slope-intercept form because y is all by itself on the left-hand side of the equal sign. However, you will notice we do not have any x containers or ponds in the problem. You might recall that adding 0 to an equation does not change the value any. Therefore, it might be advantageous for me to go ahead and add 0 x's. 0 x's is still a value of 0 and therefore has not changed the value of my equation at all, but now it allows me to find the slope and y-intercept. In this particular equation, 0 is the slope, and I'm going to go ahead and put that over 1, and the y-intercept is at negative 3. The y-intercept would be at 0, negative 3. So let's graph this equation on our graph paper. I'm going to start at 0, negative 3 on the y-axis, and I'm going to slope rise 0, run 1. 0, negative 3 on the y-axis would be here. And when I rise 0, that means I am not going up or down any. I'm simply going to run 1. This means the line is completely horizontal on the graph. It might be helpful to note that every single point on this line has a y-coordinate of 0. This point right here is 1, negative 3. This point right here is 2, negative 3. This point way over here is 5, negative 3. Every point on this linear equation has a y value of negative 3. It is also possible that the constant term could appear to be missing. So take, for example, y equals 1/2 x. This is still considered slope-intercept form as the equation has been solved completely for y. Again, it's advantageous for us to add 0 to the equation because it does not change the value any, but it will help us identify parts and pieces we need in order to graph. Slope for this equation would be here, and the y-intercept for this equation is going to be at 0, 0. If the constant term is missing from a given equation, the y-intercept will always be at 0, 0. Let's graph this. This time I'm going to start at the origin. That is 0, 0 on my graph. My slope says to rise 1 and run 2. Notice my slope is positive, and as I look at this graph, reading it from left to right, the line is headed uphill. My last two examples will require us to do some algebra to solve the equation for y. Let's start this time with 4x plus y equaling negative 9. This is not considered slope-intercept form. It needs to be rearranged so the y's are on one side of the equation all by themselves. This means we need to zero out these 4x pawns. To do that, we're going to put negative 4 pawns on that side of the balance beam, which means we must do it on the other side to maintain balance. These pawns zero out. The equation then is y equals negative 4x minus 9. If you chose to write negative 9 minus 4x, that is absolutely okay. Order of those two values is not critical. as long as you keep the negative signs with the correct numbers. Please know that you may not combine the -9 and the -4 to make -13, as those are not considered to be like terms. Once we've solved for y, we can easily identify the slope as the coefficient of the x-pons. Let's put a 1 underneath that so we have a rise and a run. And we can easily identify the y-intercept. Keep in mind the sign in front of that constant is part of the y-intercept as well. The y-intercept of this particular equation will be at 0, -9. If I were to graph this equation, I would start at -9 on my graph paper, and my slope says down 4, right 1. Obviously, that is going to fall off of my graph paper, so I am going to choose to put the negative sign with the 1 instead of the 4. This means I will be rising 4, but I will be running -1. An easy way to check to make sure the equation is graphed correctly is to check to see if it is going uphill or downhill. This line is headed in a downhill direction, which means our slope should be negative, and it is. You would not be complete if we didn't work an equation with fractions. I know, you're moaning now. But we need to be able to rearrange equations that include fractions as well. This is my final example in this video lecture. Let's solve 2/3 x plus 1/2 y equals -1. One strategy we discussed in class is to go ahead and multiply by the LCD. In this particular problem, the LCD would be 6. Therefore, I'm going to go through and multiply each and every term in the equation by 6 over 1. Do not forget to do it on the left-hand side of the equation as well. This is a common mistake for students to forget to multiply the right-hand side of the equation by 6 as well. 3 goes into itself once and into 6 twice, so this reduces to 4x's. 2 goes into itself once and into 6 3 times, so this reduces to 3y's. This side of the equation would equal -6. This is still not in what we would refer to as slope-intercept form. I still need to isolate the variable y on one side of the equation all by itself. To do it this time, I'm going to put -4x's to zero out my x-pons on both sides of the equation. Once again, we cannot combine the -4 and the -6 because they are not like terms. And then I am going to divide everything in this equation, everything being the key phrase here, by 3. This means my slope-intercept form is going to be y equals -4/3 x minus 2. The slope of this linear equation is -4/3. The y-intercept of this linear equation is 0, -2. We will finish this video lecture with a graph of this linear equation. I am going to start by plotting the 0, -2 on the y-axis first, followed by my slope of -4/3. 0, -2 is here. Rise -4. Run +3. Once again, an easy check is to look at the line, read it from left to right, Determine that this line is headed downhill, therefore the slope is negative. Your assignment for Monday for this video lecture is a worksheet entitled Slope Intercept Form. I passed copies of this worksheet out in class on Tuesday prior to my absence, but they are also uploaded into Moodle should you need another copy. Please be prepared to hand this assignment in on Monday completed. Once again, if you run into questions or concerns, please send me a Moodle message and I will respond to it as promptly as possible. Enjoy your weekend. See you Monday.